Welcome to this Save on Energy webinar. I actually just double checked. It's the fourth event in our training series for Ontario Municipalities. This session is focused on an introduction to existing building commissioning for folks who manage municipal building portfolios. That's all of you. Our presenters today are Megan Wallace and Eddie Cloutier from BPA. Their team delivers existing building commissioning services here in Quebec, Ontario, and across Canada. And they have been working with us on all of our courses around existing building commissioning. I'll talk a little bit more about those in just a moment. My name is Jess Burgess. I'm with the Canadian Institute for Energy Training, and I'll be just facilitating the discussion today. This is a 90-minute webinar, but we do have a big chunk of that time is saved for discussion and your questions at the end. So as we're going through during Megan or Eddie's presentation, if you do have a question you'd like to share, feel free to do that using the chat. Depending on your question, we might address it right then during the discussion. But if we don't worry, we've logged it and we're going to come back to it during the Q&A session at the end. And we do have plenty of time for that, so we should be able to get to all of the questions then. Briefly, our agenda today. I'm going to speak very quickly just to make sure everyone here is aware of the incentive program from Save on Energy for existing building commissionings that your municipalities should be eligible for. And then we'll turn it over to Megan and Eddie from BPA to really present an introduction to existing building commissioning, or EBCx, as I think we'll call it. So an overview. What are some of the typical measures that you might see in an existing building commissioning project? What are the general, to kind of give you an outline of costs and benefits? I think one of the really helpful things is just to start to understand, what makes a good candidate, what makes a building a good candidate for EBCx, and then get a little bit into what are some of the most important roles and responsibilities, like who's involved, what should you expect from an EBCx provider, or what should you expect that your staff needs to contribute to a project like that? And then dive into the process and roles and what's going to come out of it in some more detail. You should come out of this discussion having a good basic understanding of what an EBCx project might look like, what it would entail for your team, and what some of the outcomes might be for your building and for its energy performance going forward. I do quickly want to point to some other EBCx related materials that we have available from Save on Energy. So there have been a number of other webinars we've already done in a separate EBCx series. Some of them go into more detail specifically on some of the key measures that come out of EBCx projects, and then a two-part webinar series diving into the investigation phase specifically. That one is a bit more technical, so that's more, I think, if you are, you're getting into an EBCx project, want to understand it better, or you're actually interested in implementing EBCx projects in your own facilities or as a EBCx agent. We've also put together some practical guides, information sheets, and more information about other training courses that are available. All of that is on the Save on Energy training and support website. There's a link here, but I'll also drop a link in the chat here in the next few minutes. Importantly, Save on Energy, in addition to those information and education materials, also has an incentive program for your EBCx projects. So the program provides incentives that are staged according to these three key steps in the process. First, there's an incentive to actually conduct the investigation. That's going in and looking for the opportunities to optimize operations in your building. Then once you get into the implementation phase or construction, there's an incentive there to support the cost of implementing those measures. and then into the persistence or handoff phase of the project after it's done and you're looking to maintain those energy savings over time, incentives at all three phases along the way. You can find more information about the incentive program on the Save on Energy website. You can go to the programs for commercial sector, but again, I'll just drop a link to that for those of you who are interested into the chat in just a moment. I do also want to note, stepping really briefly outside of our main topic of existing building commissioning, because this is part of our series for municipalities, and the Save on Energy Strategic Energy Management Program is recruiting right now for a cohort for Ontario municipalities. So if that's something you're interested in, Strategic Energy Management, that program provides a range of support in setting up an energy management program within your municipality, and then you kind of work with a coach over a period of time together with a group of other similar organizations. In this case, it'd be a cohort of municipalities receiving that support together, putting your energy management program into place, and then identifying and executing projects and receiving incentive support along the way. If you are interested just in getting more information about that strategic energy management cohort for municipalities that's coming up, I will put an email address into the chat again in just a moment. You can send an email there for more information, or if you're interested, we can hang on and talk more about that during the Q&A session at the end. Okay. Stepping back into our main topic for today around existing building commissioning. And here I'm going to hand it over to Megan and Eddie from the BPA team to start by providing just an overview of the topic and what to expect from existing building commissioning. Megan, take it away. Oh, Megan, you're on mute.
Did it again. Okay. As Jess mentioned, we're looking into an overview of existing building commissioning. So what is existing building commissioning? It's an optimization process of your existing building or facility, and it looks at the inspection, diagnosis, and repair of the existing building systems. So the objective is to provide an energy optimized operation of that building. And it's generally very cost effective with a short payback period. So some of the typical EBCx measures that we see are reduced HVAC, lighting, other equipment operating hours, set point optimization for things like supplier temperature, fresh air intakes, humidity levels, readjustment of static pressure sensors, recalibration of sensors, repair of faulty equipment. We also look at eliminating simultaneous heating and cooling, verifying that terminal units such as VAV boxes are just, we adjust and calibrate those valves and dampers related to the terminal devices. The operating sequences are updated for chillers and boilers, controls updates for HVAC equipment and economizers, and also cleaning fouled heat transfer elements like heat exchangers. Eddie's going to take us on the next part.
Just a minute. So do you see my screen?
Yes, but we're seeing all your slides. There we go.
Perfect. Well, I have three examples first to present the type of measure that are quite common in existing building commissioning. So here's a first example, in this case in a laboratory building, but the measure itself would apply to any type of building, frankly. So the design of this building was that the amount of outside air admitted and lighting also varied based on occupancy sensors installed in all rooms in that case. And the design objective, of course, was therefore, obviously, to reduce energy consumption outside of busy period in the building. So during the recommissioning project, we discovered that more than 60% of the occupancy sensors were either non-functional or incorrectly configured. The result, as we can see in the image on the picture on the right, is that both the lighting and the amount of air change in the lab remained unchanged even during the night. So, of course, the very simple existing building commissioning measure consisted of reconfiguring all the occupancy sensor and make sure that the sequence of operation was as the design intention was. So it generated a lot of energy saving, of course. Here's another example. In this case, we had a cooling plant that operates in the winter season due to process loads. In municipalities, for example, this is the type of situation that will sometimes happen, for example, in arenas and certain large buildings, which must provide air conditioning 12 months a year for server room, for example. So in this case, the chillers and the network, the chill water network, had been designed to reject their heat into the heating network at low temperature, which is a very common energy saving measure now in most buildings, I'd say. Excess heat from a system is reused to provide part of the heating of the building. Unfortunately, during recommissioning, we discovered that the operator had not been adequately trained or had not understood that to operate, the chiller discharge temperature adjustment must absolutely be above 30 degrees Celsius. And that's what we see on the picture on the left. He had adjusted the rejection temperature to 18 degrees Celsius, which caused all the heat to be rejected to the cooling tower that we see on the left. And it also caused freezing problem at the cooling tower during really low temperature outside. In this case, we have rectified the set point and better trained the operators in understanding their system. As we can see on the right, for the same outside air temperature, all the energy is recovered and there is no longer any discharge at the cooling tower. So this is a second example. Third example, about the operation of variable flow pumps, and it could also be, we could have had another example for variable flow ventilators. This is in a town hall. We had several air handling units heated by a hot glycol system. During construction, the control contractor had set the pressure set point too high to control the speed of the pumps, and we can see that here at 45 psi and 30 psi. And to reach this set point, the pumps had to run at high speed at all time, and even the backup pump had to run. We completely modified the sequence so that the speed of the pump was made according to the opening of the different heating valve of the system, and that's what we see on the right, which made it possible to considerably reduce the required pressure and also, of course, the speed of the pumps to meet that set point pressure. Significant electrical saving have been generated in that case also. So these are 3 examples. I'll give back the presentation to Megan. You're on mute again. Sorry.
It's this presentation. The other ones I always remember. So the differences between an energy audit and EBCx. An energy audit looks at providing a snapshot of your building or systems and proposes measures to improve energy efficiency, as opposed to the EBCx process, which looks at the building and how it operates as a whole, and comes up with suggestions for, looks at the building on a whole under different operating conditions instead of that snapshot. The purpose of an energy audit is to replace the existing equipment. And the purpose of the EBCx is to improve the operation of your existing equipment. Long-term capital investment plan is required usually for the energy audit, whereas EBCx is a low-cost, short-term investment. And the payback on an energy audit is generally more than 3 years, and on EBCx, it's less than 2 years. For an energy audit, you would have an engineering consultant involved who usually investigates the building, develops the energy efficiency improvement plan, and then use external vendors to replace the key equipment. For EBCx, the EBCx provider investigates the building, develops an EBCx plan, works with the owner to implement it, and trains the building staff to continue the process. Then external contractors are used to perform the EBCx work, such as an air balancing contractor or BAS contractor. So some of costs associated with EBCx, you look at an average cost of about 24 cents a square foot. And typically that cost is allocated 70% for the planning and investigation phase. So a lot of work goes into the beginning stages of this, 25% for the implementation, and then 5% for that handoff and persistence phase. And typically the EBCx providers' fees are somewhere between 35% to 75% of the total project cost. Some of the factors that will influence this cost, because you can see it really varies from 8 cents a square foot to 46 cents a square foot. So some of the factors that will influence it is the availability of existing building documentation. Is there as-built drawings, up-to-date operation manuals, shop drawings for key pieces of equipment? Is there a control system, a BAS, that's easy to access the programming, and is there a possibility of implementing trend curves? What's the building area? Generally, the larger the building, the less cost per square foot. What's the number and complexity of HVAC systems? And what's the level of involvement of in-house personnel? Some of the benefits of EBCx, generally energy savings range from 2% to 14%, average of 7%. You can see an annual utility cost savings of about 24 cents a square foot, and non-energy savings of about 18 cents a square foot. Factors that influence savings are the depth of the investigation by the EBCx provider. If you're able to optimize the operation in all modes, so if you're able to do this during summer, winter, and the shoulder seasons. The building performance before EBCx, if you're already noticing some issues with the building performance and maybe it's got a higher energy usage than a typical building, there's more opportunities for savings. The building complexity, more complex buildings often offer more potential for savings. So a laboratory might have more savings than a typical office building. And what's the quality of the operations and maintenance of the building? Payback period, as we mentioned, generally ranges from 1.5 to about 2.5 years, an average of just under 2 years. You can see this graph shows the payback time for building size, and there's a bit of a sweet spot in there as well. So what are the other benefits of EBCx? During a survey of building owners, 32 out of 32 projects, the majority of the owners said the reasons were energy savings. So that's usually what people are looking for. And don't think about other things like reducing liability. But some of the other things you might see are, increased occupant comfort, making sure there's adequate indoor air quality, which I think we're a lot more aware of since COVID. Sometimes participation in utility programs such as Save on Energy is one of the benefits. And this sort of goes through a lot of this graph shows a few more benefits as well. What buildings are good candidates for EBCx? So larger commercial and institutional buildings, so greater than 50,000 square feet. Has your building changed function without a major renovation? There's usually a good opportunity there for some savings. Having an occupancy rate of greater than 75%. No major renovations planned for the next 5 years. You want to make sure that you're not improving the system and then just swapping out pieces of equipment later. Has the energy use increased over time, or is it higher than similar buildings? I touched on that earlier. There's usually a good opportunity there. If the equipment has a BIS and a building automation system or direct digital control, and does it go down to the zone level? Does it have complex HVAC equipment like lab? And is the mechanical equipment in good condition and not at the end of its useful life? So does it make sense to optimize the equipment? Moving into the process, the roles and responsibilities of all the parties involved. So the owner's role, they create and support the EBCx commissioning team. And they provide information and documentation on the building. They clearly communicate the goals for EBCx and coordinate the EBCx work. They commit financially to the project, but also with their time. They have to commit the human resources and can expect a minimum of 20 hours over the process. The facility manager is also involved in providing the documentation and will prepare a list of known problems and any opportunities that they see. And they will work with the EBCx provider to perform the testing and to verify the system operations. The EBCx provider is going to support the development of the scope of work for EBCx, perform the investigation and carry out an assessment of the building, looking at an energy analysis, documentation review, any functional testing that might be required. They'll establish the current facility requirements, review that with the owner, as well as identifying any EBCx measures and prepare an EBCx plan. They will also work with facilities management to perform the tests and to verify system operation, and support the client in developing the scope of work for contractors to implement the measures that they have identified. Contractors will also be used to assist the EBCx provider as part of the investigation and functional testing phase. That's often a BAS contractor or an air and water balancing contractor to take air readings and water flow readings. And then contractor will also be used for the upgrades and identified in the EBCx plan. So what should you look for in the skills for an EBCx agent or team? So you should look for someone who's experienced in building mechanical design. That's an asset. Knowledge of the limits of mechanical equipment, understanding building control systems, the ability to perform the energy savings calculations, and knowledge of applicable codes. So the building code, ASHRAE codes, any CSA codes that might apply. Some of the essential non-technical skills of an EBCx agent. They have to be a good communicator. They have to have the ability to talk to the building operators, to understand the issues, and the ability to explain the proposed changes. They also have to have a curiosity and an interest in challenging the established practices, and they have to have good negotiating skills.
So back to me. Thank you, Megan. So now we'll see the EBCx process in much detail, I'll say. And for this first slide, I'll go really quickly because we have all flow chart with all activities that are involved in the EBCx process. So, but basically there are 4 main phases to a recommissioning project. First, the planning phase. Second, the investigation phase, then the implementation phase, and finally, it's the end of phase. It's important to note that for the Save on Energy EBCx program, the two first phases are combined in a single phase, but it's not really important. So we'll see the process now. Okay, first, the purpose of the planning phase is essentially to establish the boundaries of the project, which system will be included or not, to define roles and responsibility, and to form a strategy for carrying out the investigation and research of recommissioning measure. This is what we'll see in detail in the next slide. The EBCx plans support the decision to proceed with the EBCx project or not, and provide a roadmap of the entire process. And the EBCx plan is basically the deliverable of the first phase. So in the next slide, we will present the activities of an existing building commissioning project to you as a flowchart. And for each activity, you can see in blue over each activity who is generally involved in carrying it out. First, there are usually some preliminary activity where the building manager will select the building forming part of the project. That's this phase here. And validate whether there's a potential for saving, often by doing a benchmarking exercise to compare performance to other similar building, and select also the EBCx provider before starting the project, of course. Then there is the traditional kickoff meeting where we clarify the role and stakeholders involved, the communication process, how information will be shared between the participant, and the work plan and the timeline of the project. To facilitate the work of the EBCx provider, the owner must gather as much information about the building as possible. Here we see the list of information typically needed. It should be understood that the more information you have, the easier the work of the EBCx provider will be. And also, of course, if, well, more information also mean that it is generally less costly, less expensive to do the investigation process. It's also important to gather information on the future of the building. Are there any upcoming renovation project? Are there any changes to occupancy planned, etc.? This information is important since, for example, if part of a building needs to be renovated in the short term, it may not be worth putting a lot of effort into an EBCx project or for this part of the system that will be involved in the future project. The EBCx agent will review the quality of the information obtained and also carry out an analysis of the energy consumed in the building. For the energy analysis, the objective is to see how the building evolves over time. For example, is consumption increasing over time? Are there any anomalies? And also to make an initial assessment of the savings potential. If the building consumes much more than similar buildings, this is often a good sign that an existing building commissioning project will be beneficial. The agent will also do a walkthrough of the building with the operator and also do a first superficial analysis of the building control system. In the control system, certain elements can influence the ease of carrying out a recommissioning project. For example, if the control system is very old and outdated, no longer supported by the manufacturer, it may be difficult to make changes and even to analyze how the system are operating. In this case, it might be wiser to first do a control modernization before attempting to make any optimization. All these activities will lead the EBCx provider to decide on a very essential question: is the building really a good candidate for an EBCx project? So there's a number of reasons why a building might be a poor candidate. Megan touched that subject a little bit earlier. For example, too many systems are outdated and due for replacement. The building already performed much better. It's another example where might be not really a good idea to do an EBCx project. I just talked about the case where the control system are outdated and it's very difficult to have information from it. And also if too large a part of the building will be renovated or change use. So these would be cases where the building might be a poor candidate. If the building is a good candidate, the deliverable of the planning phase is the EBCx plan, which will present the results of activity already accomplished and which will also plan future activities. Normally in an EBCx plan, we will also have three important appendices. The first document is on the current facility requirement. This document will be used to establish what condition must be maintained inside the building, which in some way becomes the minimum to be respected in establishing recommissioning measures. The second document is the diagnostic monitoring plan. In this document, we will present all measurements needed to validate the proper functioning of the system. Some data logging will be added to the control system, the BES system. In some case, measurements by portable recorder will be specified, or even sporadic measurement with a balancing contractor or electrician might be needed. Finally, the last document is the plan for the functional test to be carried out. Functional tests are meant to validate how the system reacts to detect if there are any deficiencies to be corrected or lower performance than expected at design. This is a very important part of the investigation process. Then the EBCx plan is, of course, presented to the building manager, and the project usually moves to the investigation phase. The investigation phase will enable the EBCx team to analyze system operation in detail, and this is really I would say, the core of an EBCx project. This is where you're going to analyze in much detail all the way that the system are operating, how the operators understand the system and set the set point or the different mode of operation of the system. And this will generate at the end what we call the findings log, which is, I would say, the most important deliverable of the investigation process. And in the finding logs, you will see all the measures that will be suggested to the client or the building owner. So what do we do in the investigation phase? Basically, it's a lot about a functional test. So you can see here a different type of system that we will need to test. The first one, of course, is to set up the diagnostic monitoring on the BES system, so at the control station. So we will either create, well, it's always a good option to create a remote access to the BES system because it will highly facilitate the work of the EBCx agent. But if it's not possible for example, security reason or other reason, it's also possible to do this, to do the work all on site. So basically, we will implement trend curves in the BES system to know how the system are operating during a week, a day, during the night, etc. We will also set the diagnostic monitoring for portable data loggers. So if we need any portable recording equipment, this is where we will install them for a specific span, specific time. We'll also do other measurement with balancing contractor, electrician, and so on. And we'll also do, and it's much important, I would say it's the most important work of the investigation, all the functional tests. So functional tests will usually be accomplished on, I'd say, at least 2 consecutive seasons, and even better, 3 consecutive seasons. So you can see the system operate during the summer, during the winter, and during the shoulder season. Because of course at least the HVAC system, the heating, ventilation, and air conditioning system usually operate in different modes during a year. And if you want to see all the potential deficiencies and EBCx measures, you need to see the building operate on these different seasons. So the EBCx agent accompanied by the building operator will do winter functional tests, for example, on boilers, heating pump, ventilation system used for heating the building, and so on. He will also do the summer functional tests, and in that case, of course, we'll focus more energy on chillers, water cooling towers, pumps, chill water pumps, and all these systems. We'll do a functional test on air handling unit, dedicated outdoor air system, air-to-air heat recovery. Also functional tests on what I call terminal systems, such as VAV boxes, fan coils, lighting system detection, occupancy detection, and all these minor system, but still important. There's also another activity that is quite often carried out, is the light out audit, and it's basically really simple to do. You visit the building outside of normal occupancy hour to see what's still running and why. So basically, you'll find a few EBCx measures just by doing that. Once all these activities are completed, there's the EBCx agent will, I would say, analyze all you've seen in the building, all the results of the different functional tests, and this will bring him to propose EBCx optimization measures. So basically, all the other activities done during the investigation phase will bring him to complete the findings log, sorry. And inside of this document, usually you'll have it's basically a table with the description of the targeted building system that were analyzed, the improvement opportunity identified, and the description.
Oh, I think we might have lost Eddie there.
It looks like a
connection issue.
I am still here,
Okay.
so I can take over. I will just have to share my screen. Hold on just a minute.
Great, thank you.
Here we go. Oh, brought me back to the beginning again. Okay. So yes, Eddie was just finishing up the phase 2 of the investigation phase, and I think he mostly finished it. So basically, the last phase would be the last portion is to prepare. Yes, he was discussing the findings log and the presentation to the owner of that findings log. From there, the discussion with the owner of what parts of the investigation should be moved into the next phase, which is the implementation phase. So the implementation phase, of course, is the phase that consists of choosing out the best method for carrying out the type of implementation and optimizations that the EBCx agent and the owner have decided on. I'll mention this, we've mentioned a couple times already. We have the implementation phase and the handoff phase identified in two separate sections, phase 3 and 4. In the Save On Energy program, it's actually both fall under phase 3. So implementation phase activities. As I was saying, the building owner and the EBCx provider will select the implementation method that they want to do, and that can vary depending on a few different factors, how much the owner's involvement, how much the owner wants to be involved, and how level skilled in-house personnel, and how much they want to keep the EBCx provider involved. So some of the measures will be able to be taken in-house, such as schedule changes, simple programming modifications, then maybe some calibration of sensors. Often in-house facility management can handle that. Or and then in that case, the EBCx agent would prepare the implementation documents to hand off to the in-house staff. Other methods will require an outside contractor, such as controls contractor, air balancing contractor, other types of contractors. In that case, the EBCx agent would provide the technical specifications, any drawings that are required, prepare the tender documents. And at that point, the EBCx agent would also help with the procurement phase. So bidders' invitations, answering any bidder questions, tender opening, this type of work.
Great. And I saw that Eddie rejoined us. Megan picked up where you left off and finished up the implementation phase and has gotten us started going through, wrapped up investigation and gotten us started on implementation.
Perfect. I have absolutely no idea when I was disconnected, and well, I guess it went well with Megan. Perfect.
It was right at the end of yours.
Great.
I was about to start up anyway, so it worked out well. All right, so next step of the implementation activities is implementing the activities and doing functional testing to see if the results are achieved. If they're not, some fine-tuning might be involved and adjusting the types of methods, and then we would do the functional testing again. If the measures are successful, then we move on to preparing the implementation report. The EBCx agent would handle that as well. The report's going to describe which measures were successfully implemented, any adjustments to the measures that were required and why, what measures were not implemented and why, and recommendations for the persistence phase, which is phase 4, the persistence and handoff phase. So the objective of this phase is to ensure that all of the knowledge that we acquired during this whole EBCx process is preserved and passed on to the O&M staff, and also to aid them in continuing to maintain these improvements. So as part of this phase, the EBCx will prepare training on the new system modifications. And it'll usually describe the changes and their functions, any adjustments that were made to the EBCx project, so any changes to the measures that were required. The EBCx agent will also put together a proposal of persistent methods to be implemented. So these often include things like energy management and verification, any additional monitoring tasks that might be required by the O&M staff, and may include also some remote monitoring by the EBCx agent and periodic site visits during the first year to make sure that everything is being maintained. The EBCx agent will put together these proposals, review it with the owner, and then together they will come up with what strategies will be implemented. The EBCx agent will provide the training for operator training so that the operators have full understanding of what's required. And then we'll move on to the final column of this slide, which is the operator monitoring task. So after the operating trainer, the operators will take on their new role monitoring and validating the changes, verifying that any key BIS parameters are in place, and basic routine maintenance tasks. The EBCx agent or the building manager will perform monitoring and verification to ensure that the results we're expecting to see are happening, often monthly or quarterly. And these measures are use a protocol, standard protocol such as IPMVP. And then lastly, the EBCx agent will do some remote monitoring and periodic site visits, as I had mentioned earlier. And then provide, I should also mention that also provide ongoing support and training as required to maintain the measures. So one of the things after we've gone through that process, we look back and see, is the building and the EBCx measure performing as expected? No, then we're going to want to go back, do some fine tuning, maybe some more training and additional support. If things are working as expected, then the EBCx agent will prepare the final report. And that one will include what measures were successfully implemented, any adjustments that were required during that first monitoring year, the energy savings from that first year, maintenance procedures, and any additional recommendations for future action. And then the final handoff happens.
Great, thank you. And we did get some questions as you were going through the phases. So thanks for that. And everyone else, feel free to share your questions in the chat or in a moment after we've gone through the ones that we've received so far. You can open up your mics and jump in with questions. But first, we had a question from Desislava just about how long does it typically take to complete all of the phases of a typical EBCx project? Eddie, I know you spoke to this a little bit, sort of referencing kind of the need to get see performance in different seasons. Do you want to go a little bit deeper into that?
Yeah, well, usually it depends on, well, first, the investigation process is usually accomplished on 3 consecutive seasons. In some cases, some clients decide only to do 2 seasons, let's say winter and shoulder season, and they don't do the summer season. It might be okay depending on the type of building. And so basically, I would say planning plus investigation is usually from, I'd say, 4 months to 8 months, depending on your choice on that. And implementation is quite fast usually, but again, it depends. If you have some measure where you want to, I don't know, replace a variable frequency drive because they are unfunctional or something, well, it could take a few months to do the implementation process. So I'd say the whole process will take between, I'd say, 8 months to a year usually. And of course, after that, the end-off phase is usually done during the month after the implementation. So it will take a few months also for that, but the important part of the investigation and implementation of measure will usually take from 8 to 12 months.
Great. And then I wanted to come back or had a question based on a portion that Megan, you presented near the beginning that I think is related to what Eddie was just speaking to about kind of the length of time for a typical EBCx project, which is, you talked a little bit about, what's the difference between an EBCx project and an energy audit. I wonder, could you talk a little bit about, when is it that I might want an EBCx project or an energy audit, and how would I kind of decide between those two based on what I'm trying to achieve?
Well, it happens quite often that we do both at the same time, but it's not necessary, of course. Usually, the energy audit will have different goal. Project owner, building owner or project manager will usually need the energy audit for different reasons. It might be for the BOMA-BEST certification. It might be to really analyze the building and determine what I would say a more expensive measure should be implemented to reduce more significantly the energy consumption of the building. Because as we said earlier, usually the EBCx process will generate savings around 5 to 15% of the energy consumption. But if you want to go deeper than that, you will need the energy audit. Also, if I'll give other example, if your boiler plant is outdated and you're due to replace it anyway, it's going to be a good time to do an energy audit to see, how can I replace that with something that will be more efficient and more using more renewable energy, for example. So this is more cases where you will need energy audit. Rather than EBCx, where you basically want to optimize what you already have in the building. So it's two different type of project, but as I said earlier, it happens quite a lot that we do both at the same time, because of course you're analyzing the same systems in the same building.
Thank you. And then we also got a question from Cynthia, again, coming back to the phases of EBCx projects, wondering about which ones of those phases or what steps could be completed with in-house expertise or working with like sort of an in-house EBCx agent.
Well, from a technical perspective, there's no limit on what you can do in-house if you have people with knowledge of, I'd say, mechanical, electrical system, because you need to have someone that know the limit of the different type of systems. So they don't want to try to optimize something and break the system because they've gone too far, or they didn't know that a specific system could not do what they wanted to do. So if you have people with good knowledge of building mechanical and electrical, plus good knowledge of BAS system, so control system, you basically can do 100% of the project in-house. And I've seen project where we were working with people in-house. I'll give the example of McGill University. They've got their own control technician, so they were able to do the programming, the calibration of the system, and most of the implementation of the measure in-house. But they wanted us to do the investigation to challenge the existing practices, but the implementation was done in-house in that case. The limit of using in-house resource is exactly that, is usually they have other things to do. So it might take longer to complete the process because they will do it when they have time. So that's, I'd say it's the limit of that idea. But if you have your own energy champion and they have all the time to do that, they might be able to do it, absolutely.
Great, thank you. I was just going to add only that One consideration there also is if you are thinking of participating in the Save on Energy EBCx incentive program, you need to work with one of their qualified EBCx providers. So the program maintains a list of EBCx service providers, and in order to go through the program and receive the incentive support, you do need to work with one of those companies. And I think that maybe addresses Desislava's second question there. So going through the EBCx incentive program, I don't think you can, the program does provide a list of qualified service providers that you can then engage for your projects. Richard just asked if the slides will be shared. Yes, they will. I put the link in the chat a couple of times to the training and support existing building commissioning page. The recording and the slides will be up on that page in about a week. So everyone should have access to them. As well, if you're interested in, we talked about some, well, we've had some events that have gone in more detail into the investigation phase, the functional testing. If you're interested in more of that detail, there are webinar materials and recordings on that page. In that case, you'd be specifically interested in the investigation phase essentials webinars part 1 and part 2. There's also a webinar on going deeper into some of the key types of energy savings measures that come out of EBCx projects. All those materials are available on that page that you can access. I also would be remiss not to mention the next event coming up in our Save on Energy training series for municipalities. So I just dropped into the chat our training calendar. So all of our webinars and training events are there at saveonenergytraining.ca at that link. But you can also see our next event is coming up on March 7th. That will be the 5th event in the municipal series. And that's focused on financial analysis for energy efficiency projects for municipalities. Let me see, we've got a question from Anchor. How effective is EBCx if implemented through remote devices controlling the BAS based on predefined algorithms instead of on a manual exercise? Ooh, that's a good question.
That's a good question. Well, I'd like to maybe ask a question about the question. When you say implemented through remote device, do you really mean that? Because I mean, most of the time, the change that we will propose in EBCx will need to be validated on site to make sure they don't create another problem. So there's not a lot of stuff that we will change without being on site to make sure that we're not, I don't know, creating a pressure problem somewhere or a temperature or so usually you need to be on site to make sure that you're not breaking something else. That's why I have my doubt about this method. I'm not saying that there's a few software that exist that are basically doing part of the investigation process by doing, I'd say, automatic analysis of the BES system. So maybe it's what you mean by this question, but usually doing the implementation is always done by control technician and building operators.
And Anchor, feel free to open up your mic and chime in if you have any follow-ups.
It's just that we've come across some, vendors who claim to, do the building commissioning through remote devices. Of course, those devices would be controlling the HVAC equipment within a certain range. They won't get a free hand in that sense. So I was just wondering how effective and such an insight could be.
Yeah, I know a couple of these software or I'd say BS vendor who propose things like that, but usually they stop at trying to do part of the investigation or I say automatic detection of the fault and analysis. But I've never seen them controlling the system over the BES system, because there's I don't know if their insurance would like that, frankly. I personally, I would not let them control over the BES system if I was the project owner, the building owner. Yeah.
Great, good question. We have another good one from Kyle, who says they're presently undergoing building condition assessments for all their facilities. Once those are complete, would those reports be helpful to pass over to the EBCx agent, or is that overkill?
Normally they would, yeah. Depending, of course, of the quality of the information included in the BCR or building condition assessment. This information will be useful to the EBCx agent, because usually you have some characteristic of on the air handling unit, a different type of mechanical system, and so on. So it's always good information.
Great. Thanks, everyone who shared questions. Other folks, please chime in. You can use the chat or go ahead and open up your mic and join the conversation. Maybe I'll ask, I'm just curious for these, questions around where would I want to start? How would I want to approach the idea of EBCx? So I'm just curious for the types of buildings that you typically see in a municipality's portfolio. And I'm thinking of, as we discussed, Eddie, things like fire stations, arenas, rec centers. Which, in your experience, what among those types of buildings tend to be a good candidate or offer savings potential for EBCx?
Well, the more complex are usually the one with more potential. And in municipality, what I've seen in the past is usually arenas has a lot of potential, depending on the type of system, of course, but most arenas now have heat recovery. And I haven't seen a lot of them work properly, I'd say like that. So there's a lot of potential in arenas. Aquatic center would also be, if you have an aquatic center in the municipality, there's a high potential there, because usually, again, you have these dehumidification systems that are relatively complex to operate. And I'd say they usually have higher potential. If you have municipal garage for truck repair and all that stuff, there's usually a lot of fresh air involved in that kind of building, because you have all the process and the trucks that are running inside the building. So there's a high potential there also. Of course, you have more basic type of buildings, such as the city hall, that is basically an office building for me, from a mechanical electrical perspective. But still, these are potential good candidate for EBCx, of course. At the other end of the spectrum, I don't know, chalet de parc, or these small building inside park. Usually not interesting, because there's nothing complicated in that type of building, so not a lot of potential.
Yeah, great. A couple of questions came in about the EBCx incentive program. So I brought the slide back up. To your question, So as we talked about at the beginning, there's kind of a three-phase incentive, one for the investigation activity that's primarily carried out by the EBCx agent, then a incentive for the implementation phase that would include activities like air and water balancing, and then another incentive for the handoff and persistence phase. And then Desislava asks, can you combine the Save on Energy incentive with other incentive programs? So I believe the answer is not within other Save on Energy programs. So if you did an EBCx project and it went through the EBCx program, you could not get additional incentives from another Save on Energy program, like, for example, the Energy Performance Program or Strategic Energy Management. GMF-CBR, I'm not actually familiar with what that is. If it's an external program, like a Government of Canada type of program, then you may be eligible to stack those incentives, but you probably want to double check. Great. Are there any other questions from folks? If not, I'll just remind everybody our next event in the municipal series coming up on March 7th, focused on financial analyses for energy efficiency projects. And again, refer you to our training calendar that I dropped the link for that in the chat a few minutes ago. You can see all of our upcoming webinars and events in the municipal series, but also in other areas, including we have a lot of activities coming up around heat pumps, around electrification, and some things for other sectors as well. And then, as we mentioned at the beginning, if you're interested in that cohort of municipalities coming up for the Strategic Energy Management Program, you can just write to sem@ieso.ca, and that's in the chat as well near the beginning for more information about that. I'm sure that program team will be happy to get back to you and tell you more about it. Kyle asks, off topic, but we're looking at installing a BAS at one of the facilities. Is there an incentive through Save on Energy for installing the BAS system? If so, who can you contact? I think for something like a strictly controls measure like a BAS, I don't believe there's a straightforward, install a BAS, get X incentive dollars for it. But there is, you may be familiar with the Energy Performance Program, and the way that program works is you enroll and measure an energy baseline performance of your building, and then it tracks the performance of your building over time, and you receive an incentive for energy savings against that baseline. So the idea is you get started in that program and begin doing things, maybe installing an automation system, automating some of those processes for efficiency, start saving energy, and then you receive an incentive for your energy savings that are achieved over time. So that program, it's called the Energy Performance Program. In a minute, I can drop the link to that in the chat. Any other questions before we wrap up? Great. Well, thanks to everyone for sharing your afternoon with us. A big thanks to Megan and Eddie for a great presentation. And I look forward to seeing you all again on March 7th. And maybe at some of our upcoming events between now and then. Take care, everybody.
Thank you, everyone.
Thanks.